All right, today we're going to talk about one of the unsung heroes of electronics, the inductor. You'll find this little guy in pretty much every device you own, so let's break down exactly what it is and what it does. Have you ever wondered how your radio can just magically tune into one station and block out all the noise? Or how that power brick for your phone takes the messy electricity from your wall and turns it into a smooth, steady charge? Well, the answer to both those questions, and a lot more, is the inductor. Okay, so let's start with the big question. What exactly is an inductor? Before we can get into all the cool tricks it can do, we really need to understand what we're looking at. At its heart, an inductor is actually super simple. It's really just a coil of wire. That's it. When you run an electric current through that wire, it generates this powerful, invisible magnetic field all around it. And that magnetic field, well, that's the absolute key to everything. So if we look at its basic anatomy, there are just two main parts. You've got the lilitan kawat, which is the wire coil itself, and then you have the inti, which means the core. Now that core can be just air, or you can put a piece of magnetic material like iron in there to really concentrate and boost that magnetic field. Now, the one property that defines every inductor is something called inductance. We use the letter L to represent it. And what inductance measures is pretty simple. It's the inductor's ability to fight back against any change in the current flowing through it. We measure this in a unit called the Henry, or H for short. And if you ever find yourself looking at a circuit diagram, this is what you'll see. This little looped squiggly line is the universal symbol for an inductor. It's actually a pretty great symbol, right? Because it looks just like what it is, a little coil of wire. All right, so now that we know what it is, let's get to the really interesting part. How does this simple coil of wire actually work its magic inside a circuit? The best way to wrap your head around this is with an analogy. I want you to picture a big, heavy flywheel. It takes a ton of effort to get it moving from a dead stop, right? It resists that change. But once it's spinning, it wants to keep spinning. It has inertia. It also resists any attempt to slow it down. An inductor does the exact same thing, just with electric current instead of physical motion. Now, this gets to the very heart of it. That formula might look a little intimidating, but the only part you need to care about is the dIdt. All that means is the rate of change of the current. So the inductor doesn't care how much current is flowing, it only cares about how fast that current is trying to change. If the current is steady, the inductor's totally fine with it. But if you try to change it quickly, that's when it fights back. And this unique property, this hatred of change, means that an inductor behaves completely differently depending on the kind of circuit you put it in. Let's look at the two big scenarios. On one side, we have a DC circuit, direct current. It flows nice and steady in one direction. To an inductor, that's like that flywheel spinning at a constant speed. No problem, the current just passes right through. But on the other side, we have an AC, or alternating current, which is constantly flipping back and forth, always changing. The inductor resists this like crazy, and that right there is the inductor's most important superpower. So why is that superpower so useful? Well, this ability to treat AC and DC current so differently allows an inductor to perform three main jobs in the world of electronics. This gives us a really great overview. You can see the inductor right there in the middle of it all, and branching off from it are its three core functions. Let's break them down. Okay, first, its most fundamental job is what we've been talking about, resisting changes in current. Now, that directly leads to its second job, filtering signals. If it lets steady DC pass but blocks fast-changing AC, then poof, you've got a filter. This is exactly how a speaker can send the low, thumping bass notes to the big speaker cone. And third, that magnetic field isn't just for show, it's actually storing energy. Yep, just like a stretched rubber band or a compressed spring stores potential energy, an inductor stores energy in its magnetic field. How much energy it can hold depends on its inductance and how much current is flowing through it. And then it can release that stored energy back into the circuit, which is absolutely crucial for things like power supplies. So, after all of that, let's boil it all down. What's the single most important thing to remember about an inductor? Let's wrap this up. If you take away just one thing from all this, let it be this. An inductor is a current controller. That's its whole purpose in life. Everything else it does, the filtering, the smoothing, the energy storage, it all comes back to that one core job of managing the flow of current by resisting change. Of course, inductors don't work alone. They're part of a team, working with other components like capacitors and resistors to make all of our amazing gadgets work. So the question is, what components should we break down next? Let us know. Thanks for tuning in.